Hello, we are Team 336-2 TriBURN Industries. I am Ryan, Head Robot Builder.
I'm Madeline, the Robot Communication Specialist.
I'm Devin, Programming Expert.
This year's project involves an autonomous tank playing a turn-based strategy game against a human-controlled tank, which is controlled from this control panel.
The rules of the game are that each player gets 2 actions per turn, move forward 1 square or fire. Rotations in place are a free action that don't count towards this turn count, and the game ends when 1 robot is shot or the clip that has 6 shots in it is empty. Devin?
This robot is equipped with an AI and will be playing against the human-controlled robot. The robot uses an algorithm I will go into later to go to the other robot's position and fire at it. Now let's see it in action.
You can see the control panel, which is the command center for the entire project. The control panel uses a string format to set up strings using the sensor readings, various letters, and integers to send a message that the other robots will then parse.
And the AI bot robot now is moving to intercept the user bot using a proportional line follower.
So the AI robot has received a message from the other robot. This is called go message. It consists of the word go and 2 numbers. The 2 numbers are the user-controlled robot's coordinates. The AI robot will take those coordinates and subtract from them its own coordinates. That will give us the change in X and the change in Y.
The user bot is now taking its turn, or the human is controlling the user bot taking its turn. Driving away from the AI robot, making it chase it.
You can see that when the robots move, we use the proportional line follow because it's smoother. We measure the error between the actual measured light sensor value and the ideal sensor value and use a proportional constant multiplied by that error to proportionally adjust the motors.
So the robot has to keep track of which orientation it is on the map, and it does that by using modular algorithms. Also, the robot, when attempting to fire at the other robot, it uses 2 different elevations depending on which square we are in.
The user bot is also now attempting to try a risky, very long-range 3-square shot.
So the user bot has missed, and now the AI has once again received the go message and coordinates. It will now move forward. It will stop and then attempt to fire at the human-controlled bot. It can be led to the next level.
And the human-controlled bot has been killed by the AI robot.
We did all of our programming in Robot C. We have modular, reusable code and make good use of movement subroutines.
This is the AI robot. It's very similar to the user robot. It has 2 drive motors to drive. It also has 2 motors to control the firing mechanism for a grand total of 4 motors. The additional motor is controlled using this Mind Sensors motor multiplexer. It also have 2 light sensors so they can navigate their squares. A angle sensor in the funnel so that they know they've been hit when the shot enters the funnel. And an NXTBee radio for communication with the other robots. This is the control panel. It has an XB radio for communication with the other robots. 4 touch sensors wired into a touch sensor multiplexer to control the movement. It also has a firing button, which when this reads the value of this lever, which controls the elevation of the firing mechanism, then tells the user robot to execute the firing program.
We believe that this project could be useful in helping interest kids in STEM.
It could also have a lot of uses to explore potential ways to use cooperative robotic behavior.
We hope you enjoyed this video, and thanks for watching.